Okay, hello, good afternoon to all participants joined today's webinar. So today the title of our webinar is Casting Simulation System. Before we start, please be noticed to turn on the mute button during the webinar to avoid any noise background. And secondly is if you have any questions during the presentation, you may type inside the chat box and we'll reply to them at the Q&A session later after the presentation. Okay, this is a slide shows our Cybernet System Japan company profile. Our head office located in the Tokyo, and we are established since 17 April 1985. The core business of Cybernet System is providing the CAE solution and IT solution. And we have more than 20 companies developing partners. This slide shows our Cybernet System global network. Basically, we have a development subsidiary and also a sales subsidiary. In case of sales subsidiary, we have 4 overseas sales. The first established was in Taiwan, second in China, third in Korea, and the fourth and latest subsidiary is here in Malaysia. This slide shows our Cybernet System Malaysia company profile. We are established in November 2018 as the fourth subsidiary, and our number of employees is 5, and we are located in KL, Kuala Lumpur, KL Eco City. And also our core business is same with Japan, and the partners involved is mainly NC Synopsys and Hitachi ADSTEFAN. So today's casting simulation, we will be using Hitachi ADSTEFAN to do the presentation. This slide shows our Cybernet System solution option. You can see there is CAE, AR/VR visualization, big data solution, and also IoT, digital twin, IT solution, and finally, we also provide the engineering service. Okay, so this finish up a very brief introduction of Cybernet System Malaysia, and I will pass the presentation to our presenter today, Mr. Kawamoto from Hitachi, Japan.
And it's about history of ADSTEFAN. 28 years ago, the origination of ADSTEFAN was developed at Tohoku University, and later Tohoku Technoarc Corporation is commercialized about 20 years ago, and that about 27, Ibaraki Hitachi Information Service took over all businesses from Hitachi Limited. And just now, Hitachi Industry and Control Solutions are selling and providing ADSTEFAN support service. And ADSTEFAN Partner is as follows. We are collaborating with Hitachi Research Laboratory, Tohoku University, Iwate University, and so on. In global area, we are also collaborating with Shanghai University, South China University of Technology, and so on. And by collaborating with some universities, we are adapting advanced technology to casting simulation technology. And secondly, it's about overview of casting CAE. And it is about application range of casting of CAE. We can ADSTEFAN can be applied in aluminum, magnesium, steel, copper, or stainless, and so on. So as for casting method, high pressure die casting, squeeze casting, low pressure, and gravity, and so on. So we can deal with various casting method, and it is about purpose of utilizing ADSTEFAN, and it shows effect of casting CAE. So as for designing, so we are designing runner, gate, and we are planning velocity and the temperature of metal, the temperature and position and size of about riser overflows and so on. And by optimizing through ADSTEFAN simulation software, we can realize cost reduction, lead time reduction, and the number of prototype reduction, and so on. And next is about feature and outline of ADSTEFAN. So the slide shows ADSTEFAN feature about 3 advantages. Firstly is about high-speed analysis. Second is easy operation. And last is solid foundation. And so ADSTEFAN enables to contribute to manufacturing products in factory. And ADSTEFAN is casting CA system, and that engineer can get optimal solution by trial and error in the limited time by simulating software. And about high-speed analysis, we are adopting multiprocessor technology. And by adopting this technology, high-speed analysis can realize. And second is easy operation. And so we are adapting user-friendly operation in the common menu by taking the many feedbacks from many users. And last, solid foundation, it is about development by utilization with prominent research institution and user network. So by adopting many excellent institutions, ADSTEFAN can get the reliability by many universities and users. Second is next is about ADSTEFAN system configuration. So the system consists of preprocessor, solver, and post-processor. And in preprocessor, it's about importing original model and analysis setting of analysis condition. So second, solver is consisted of fluid flow, solidification, and other optional module, and so on. And last, post-processor is viewing analysis result by which is executed in ADSTEFAN software. So this slide shows ADSTEFAN parallel computing floating version. So by utilizing multiprocessor from 1 to 2 or 4, 8, and so on, we can realize the high speed more than single core. And next, right side shows ADSTEFAN is also available as floating version. by using this in even in remote area, we can you can access the server system, and ADSTEFAN can be used in remote area. So it shows the distribution of ADSTEFAN map. Of course, in Japan, about 500 users are used in Japan, and next, India is about 53, and China is 50 licenses, and so on. And in next generation, Malaysia will also used at many users in the future. So next, about fluid flow analysis. So it shows that many defects which can be evaluated by ADSTEFAN. It shows the casting defect about misrun. So the filling situation is not so good. In this area, so molten metal is not fully filled. So, and the simulation result shows misrun defect on area, and temperature is low, and so it shows unfilled area due to low temperature below than solidification temperature. Next, it shows the example of magnesium alloy. So the model is adapted by mobile phone, and so it shows cold chat area, and the molten metal is from left side and right side is matched. And in this area, if the temperature is low, so it is border appeared in as is shown in the figure. And by showing casting temperature and contacting time with air, so it shows the risk of cold shot generation. This area. So, and next, next it shows fluid flow with mass method. ADSTEFAN adapted the technology of mass method. So by covering the drawback of finite FDM method, so FDM method which is represented by both method. So in ADSTEFAN, we are focused on mass method. It is about technology. So this flow trajectory is revised by adapting mass method. On the contrary, in conventional method, so it is a natural molten metal trajectory. So it is revised. Next, it's about the case study of high accuracy fluid flow analysis. So one example is about propeller, and second is ball shape. So it is so it shows the case study of conventional method, blended element and high accuracy fluid flow, which is adopted about 3 years ago. So it shows the demonstration. So the molten metal flow is not equal. Firstly, this is first field, but in this advanced technology, so the volume is nearly almost equal by method. So in ADSTEFAN, the accuracy of high fluid flow trajectory was revised by adapting advanced technology. So we are also showing another case study. It's about the model by ball shape. So it is the result by water model experiment. So it is actual case. On the contrary, it is the result of a simulation. So simulation result is matching to experiment result. So next, it is show die-cast intensification fluid flow analysis. It's about evaluation parameter. We can show gas pressure, gas size, and gas quantity per unit. So it shows the relation between time and gas volume. And right figure shows the effect of intensifying in high pressure die cast. If we are not intensifying in fluid flow process, so gas volume is still remained. But by intensifying, so gas volume will be reduced, as is shown in figure. So it shows the defect assessment by sleeve analysis. It shows the high pressure die cast method. So it is a product, and so before entering, we can simulate the model sleeve area. And so by visualizing with using marker, so we can evaluate the blow fall trajectory, oxide tracing, and breaking chill layer, and so on. So next, since about version 2018, ADSTEFAN can deal linking analysis fluid with moving object. So it shows the movement of plunger chip, and after stopping plunger chip, we can show the situation of molten metal in product area. So by using this function, shape and properties can be reflected in executing analysis, and parallel movement and rotation is also can be dealt with in ADSTEFAN. So next, so it shows the case study of consideration of moving object. Firstly, in high pressure die casting, from pouring by ladle to injection on the top from the top of sleeve. So ladle pouring is executed in sleeve area. And after pouring and plunger chip is also moving from left side to right side. It shows the situation of moving object function. It's pouring and after pouring, plunger chip is moving. Once again, it's shown and chip. It's okay. Next, it's about solidification analysis. And in solidification process, the typical casting defect is shrinkage microporosity. As the figure is showing in product area, the porosity is also happening. So it is that we are not hoping the phenomena. And by doing simulation, we can predict the possibility of generating this defect. So it shows the simple case study by using this test piece. And in this test piece, from the conclusion, so product is generated, the porosity as is shown in figure. So an X-ray CT is also showing the phenomena, and it is show the result by ADSTEFAN. So in ADSTEFAN, so red area shows the possibility of casting defect in porosity prediction. So in this case, this riser size is very narrow and relatively long. So in this gate design, the design is not so good. So by considering defect of design A, we saw and they are revising the gate design. So concretely, the width of gate is enlarged, and so and that the length of gate is shortened than design A. By doing this, in product area, no shrinkage was happening. In it shows the real object, and it shows the result by X-ray CT scanner, and that ADSTEFAN result shows it's only the porosity area in only in riser. In product, not happening. So, and it is also directional solidification. And second case study by simulating in steel, T-shaped steel. So if the riser size is not insufficient as is shown, so shrink area is invading product area. So in this case, the design is not so good. but by using larger riser, so no shrinkage area was happened in product area. Certainly, there is a trade-off between the size of riser and shrinkage porosity. We can clarify the result, the relation, this trade-off by evaluating simulation ADSTEFAN. So in shrinkage prediction in Castile, it shows experimental result. It is happening this and this, and so the evaluation method is has several variations, such as solidifying time, GR method. It is defined as Niyama parameter. Niyama professor was developed in Tohoku University. And last, soundness of degree, conventional method and new method. So there are three types in ADSTEFAN. So in this slide, only two examples were shown. So next, it's about dye temperature analysis. So in this, it shows the temperature of degree temperature changes. So until sixth cycle, its state the situation is unsteady. But after adapting 7 cycle, so the temperature is not changed. And it shows after first shot, and second is after 10th shot. So the temperature distribution was changed and stable. And in ADSTEFAN, by reflecting the temperature defect of the temperature analysis, we can utilize this. So it is dye stage about filling start, filling end, and its moving dye is removed. And other mode 4, 9, 10, 13s are all dyes are open. And after opening, so next filling start. Before next filling start, the time is set about 40 seconds. So it shows the example of material property. So casting mold property. So it shows temperature distribution and Niyama parameter and soundness and the possibility of shrinkage porosity. So without reflecting the temperature, so many area was happening. In many area, shrinkage was happening. On the contrary, with reflecting the dye temperature, no shrinkage was happened. It shows the demonstration of temperature. So blue area is unsolidified area, and it shows that the solidified was finished. So it is still remained unsolidified area. In right side, so directional solidification was realized. By showing the image. So it is separated from this area and this area. And when the area is solidifying, the shrinking area is still remained. On the contrary, in this case, shrink area is shifting from product to gate area. So in this case, so shrink area is moving from top to gate, and in this case, no shrink area is remained in product area. It shows special casting analysis, which is executed in ADSTEFAN as optional function. It shows tilt casting example after pulling and tilt. So second, this pulling and after pulling and tilting. So by fluid flow and by reflecting the result of fluid flow, we can evaluate solidification analysis. So it shows centrifugal casting. So that shows the difference of rotation speed, 100 RPM and 300 RPM. And so the fluid flow trajectory is as follows. We can show by rotating and without rotating style in ADSTEFAN. So it shows the thermal stress analysis on FDM software. In ADSTEFAN, by utilizing FDM software, and we can execute this analysis. But if one user is holding other FEM software such as Nastran, Abacus, and so on, ADSTEFAN can link with temperature data with other software. By using this, thermal stress analysis is thermal stress analysis is executed. It is about leak prediction. Leak prediction is released as optional module in the ADSTEFAN. So its patent, it is the patent which is claimed by Nissan Motor Corporation. And predicting risk that fluid flow in cooling paths inside products, and so inside to outside. So oil or water was flowing. It is a very large risk. So there is there is a need which automobile parts are hoping this function. So it shows the degree of risk of leaking water and oil and so on by measuring between the distance between oil and shrink area. So the shorter leak path is the risk is also bigger. So it shows the solution by linking between X-ray and ADSTEFAN. And so defect data is showing by ADSTEFAN, and And by X-ray is also inputted to ADSTEFAN. And we can overlap between ADSTEFAN result and X-ray. And by doing this, blowhole or shrinkage area can be visualized by the function of ADSTEFAN. So it's the end of the introduction of casting simulation system ADSTEFAN. Thank you for hearing our presentation.